Okay, so let's unpack this. You've got that one room in your house, right? Maybe it's like the master bedroom all the way at the end of the hall, or I don't know, the home office you're spending 8 hours a day in.
Oh yeah, everybody has that one room.
Right. And no matter what you set the thermostat to, it is just stubbornly, frustratingly hot in the summer and then, freezing in the winter.
Exactly, and you're constantly messing with it.
Yeah. You adjust the vents, you buy those expensive oscillating fans, you curse your air conditioner, but nothing seems to actually make a dent.
Nope, it never does.
Well, if you live in the South, specifically why Atlanta homes struggle with uneven cooling and how ducts play a role, it's just this fascinating puzzle. Like those uncomfortable rooms, the rising energy bills, the random dust on your furniture.
It's maddening.
It really is. But they might all be symptoms of hidden duct issues. And that is exactly our mission for today's deep dive. We're trying to understand the secret life of your home's breathing system, why it fails you, and the actual engineering required to fix it.
Which is a lot more complex than people think, to be honest.
For sure. And we are using a framework of case studies and technical data provided by our sponsor, Hurricane Group. They're Atlanta's leading IICRC certified specialists in HVAC hygiene and property restoration.
They do incredible work.
They really do. They handle everything, right?
Mhm.
Like air duct cleaning, dryer vent cleaning, water damage emergency response, high-end home renovations, and even full crawl space encapsulation.
A to Z, basically.
Yeah, exactly. And you can reach them at 404-236-6343. Anyway, to really grasp what's going wrong in that one stifling room of yours, I think it helps to think of your home as like a living, breathing organism.
I like that analogy.
Right. So your HVAC unit, the physical air conditioner sitting outside, that is the heart. But the ductwork snaking through your walls, under your floors, in your ceilings, those are the lungs.
That's spot on.
And if the lungs are congested, the heart has to pump twice as hard just to keep the organism alive, And the extremities, in this case, those furthest rooms in your house, they just get completely starved of circulation.
That biological framing is like the perfect way to look at it because, a house does not exist in a vacuum. It's constantly interacting with its environment.
Right.
And before we can even attempt to balance the airflow and, fix that uneven cooling problem, we have to look at the specific environmental cocktail the home is actually trying to survive in.
That's local climate, basically.
Exactly. And in this region, the primary antagonist is the climate of Atlanta itself. It isn't just regular weather.
Oh, definitely not.
No, it's a very aggressive, very specific combination of atmospheric conditions that fundamentally alters the interior of your ductwork.
Right, because, we're dealing with high humidity that frequently just sits at 70% or higher for months on end.
Basically a sauna outside.
Yeah, and then you throw in the infamous Atlanta pollen season, where literally everything gets coated in that thick yellow dust.
Oh, the pollen is relentless. So imagine what happens when you combine that heavy, moisture-laden air with those massive seasonal pollen counts, right? And you pull all of it into the dark metal environment of your ductwork.
Oh, man. That sounds like a recipe for disaster.
It really is.
Yeah.
Because when that microscopic pollen, along with, normal household dust, pet dander, dead skin cells, when that meets that persistent humidity, it undergoes a physical change.
Wait, it changes? Like chemically?
Well, physically.
Yeah.
It doesn't just sit in the ducts as a loose, sweepable powder anymore. The moisture actually acts as a binding agent.
Oh, gross.
Yeah, it mixes everything together into this highly toxic, incredibly stubborn, paste-like compound. The technicians who actually go in and remediate this stuff, they refer to it as Georgia sludge.
Georgia sludge. It sounds like something you'd find at the bottom of a swamp, but it's actually lining the lungs of your house.
Pretty much.
But, okay, how does a layer of sludge translate to my home office feeling like a sauna while my living room feels like a meat locker?
So that comes down to the physics of fluid dynamics and friction. Air acts like a fluid when it moves through a pipe.
Okay, tracking with you.
As this sludge builds up on the interior walls of your ducts, it literally reduces the internal diameter of the pathway.
Like clogged arteries.
Exactly like that. Even just a quarter inch of buildup all the way around a duct significantly reduces the total volume of air that can pass through it.
Wow, just a quarter inch.
Yeah. So the air being pushed by your blower motor suddenly encounters massive frictional resistance. The system was engineered to push a specific volume of cubic feet per minute to that furthest room.
But the sludge gets in the way.
Right. Because of this sludgy bottleneck, the air pressure just completely drops off before it ever even reaches the vent.
So the air just gives up halfway down the line?
Essentially, yes. The energy dissipates as it fights against the rough, narrow walls of the duct. Your air conditioner ends up having to work like 15 to 20% harder.
That's a huge margin.
It is. It's running longer cycles just to force a fraction of the necessary air through that congested pathway. That is the direct mechanical cause of inconsistent room temperatures.
Okay, that makes so much sense.
And it also explains the secondary symptoms people notice, right? Like excess dust settling on furniture literally days after cleaning.
Or those lingering pet odors that just won't go away.
Exactly. Or vents that sound unusually loud and breathy. That noise is the air literally whistling as it forces its way through a constricted pipe.
Okay, so the lungs are choked with sludge. The obvious answer is to clean them. And I know there are professional multi-step mechanical scrubbing protocols for this.
There definitely are.
But I have to stop you here because common sense tells me this sounds like a disaster.
How so?
Well, if my ducts are lined with toxic, moldy sludge, isn't blowing a high-powered vacuum in my house just going to turn my living room into a snow globe of allergens?
That's a very fair point.
Like, you're basically agitating a hornet's nest of dust, right?
Yeah, and that is actually the #1 fear homeowners have when they hear the words duct cleaning. And honestly, if someone just shows up with a glorified shop vacuum, that fear is entirely justified.
Right, you don't want some guy just blowing dust everywhere.
Exactly. True professional remediation relies on the physics of zonal containment and HEPA-filtered negative pressure.
Negative pressure, like an isolation ward in a hospital?
The exact same principle, yeah.
Yeah.
Air always moves from an area of high pressure to an area of low pressure. So before a single brush enters your vents, specialists seal off the entire system.
Okay, sealing it makes sense.
Then they attach a massive truck-mounted vacuum to the main trunk line of your HVAC system. This vacuum pulls thousands of cubic feet of air per minute out of the ducts.
Wow.
Yeah, it creates a very powerful low-pressure zone inside the metal walls.
Oh, I see. So the air inside the house is at a higher pressure than the air inside the ducts.
You've got it.
Meaning, if there's a leak or an opening, the air from my living room gets sucked into the vent rather than the dust blowing out into my living room.
Exactly. The physics make it literally impossible for the dust to blow backward.
That is brilliant.
It's super effective. So when they introduced the mechanical agitation tools, these specialized pneumatic whips and rotating brushes that physically scour the sludge off the duct walls.
They're really scrubbing it in there.
Oh, yeah. And all of that dislodged debris, the mold spores, the pollen, the sludge, it is instantly caught in that violent slipstream. It has absolutely nowhere to go but straight down the vacuum hose.
Right out to the truck.
Yep, straight through hospital-grade HEPA filters and completely out of your house. The pathways are restored to their original factory diameter.
All right, so we've scrubbed the lungs, the pathways are wide open, the air can finally reach the master bedroom without losing pressure, and the AC doesn't have to work 20% harder.
Sounds good, right?
Yeah, we've solved the uneven cooling problem.
Well, we've solved half the problem.
Wait, only half?
Yeah, because clearing the path only works if the air entering the path isn't fundamentally compromised from the start.
Okay, where is it coming from then?
Well, to understand the complete thermodynamic picture of your home, we actually have to stop looking at the ceiling and start looking beneath your floorboards.
Down into the crawl space or like the unfinished basement?
Exactly. This brings us to a crucial structural mechanism known in building science as the stack effect.
The stack effect. Okay.
Most of us assume the air we breathe in our living room comes exclusively from outside, right? Slipping in through the front door or drafty windows.
That's what I always thought.
But the reality is that a house acts like a giant chimney. Warm air inside your home naturally expands, becomes less dense, and rises.
Basic physics, right.
Right. And as it floats up and escapes through the roof, the attic, upper floor leaks. It creates a physical vacuum at the very bottom of the house.
And nature hates a vacuum.
Exactly. So to replace that escaping air, the house actively sucks air upward from the lowest possible point. Up to 50% of the air you breathe on the first floor is actually being pulled directly up from your dirt crawl space or basement.
Okay, here's where it gets really interesting, because I was reading up on the thermodynamics of this, and it absolutely blew my mind.
It's pretty staggering.
Think about what a typical Atlanta crawl space looks like in the middle of July. It has a dirt floor, it rarely sees sunlight, and the humidity is probably hovering around like 80 or 90%.
It's a swamp down there.
Right. So half the air circulating in my living room is essentially swamp air. But How does pulling up damp air directly cause my home office to stay stubbornly hot?
So it completely derails your air conditioner because of the difference between sensible heat, which is the temperature you read on a thermometer, and latent heat, which is the energy trapped in moisture.
Okay, so damp air is different.
Damp air is significantly physically harder to cool than dry air.
Because water holds heat incredibly well. It's
Mhm.
like the same reason a humid 85-degree day feels so much worse than a dry 85-degree day.
Exactly. Your sweat can't evaporate, so the heat stays trapped against you. And your air conditioner feels that exact same struggle. When your AC unit pulls in that highly humid air from the crawl space, it can't just lower the temperature right away.
What does it do first?
It has to act as a giant dehumidifier first. It spends a massive amount of its electrical energy forcing that water vapor to condense into liquid water and drain away.
Wow.
Only after it wrings the moisture out of the air can it actually begin to drop the sensible temperature.
So it's working double duty.
Exactly. An unsealed crawl space forces your air conditioning unit to work 25% harder. It's burning through electricity just to fight the latent heat rising from the dirt. It directly sabotages the system's ability to cool the house evenly.
Which totally explains the skyrocketing summer energy bills. The AC is multitasking, running constantly, and still doing a terrible job at actually cooling the furthest rooms.
Yep. And beyond the energy waste, pulling 80% humidity into your floorboards creates the perfect biological environment for structural wood rot and toxic mold.
Yeah.
Yeah, mold thrives in anything over 60% humidity. This is why the definitive engineering solution is a 5-step crawl space encapsulation protocol.
And we should clarify, encapsulation is not just going to a hardware store, buying a cheap plastic tarp, and unrolling it over the dirt.
Oh, not at all. Please don't do that.
Right?
Professional encapsulation creates a surgical envelope beneath your house. They use a 12 to 20 mil thick antimicrobial vapor barrier.
That is heavy duty.
It really is. It is highly puncture resistant. Every single theme is double sealed with waterproof tape, and it runs completely up the foundation walls.
So nothing is getting through.
Right. They permanently seal off the exterior vents to stop the humid Georgia air from constantly replenishing the moisture. And then they introduce the final critical piece of machinery.
The dehumidifier.
Yes, an industrial-grade dehumidifier.
And these are serious pieces of equipment, right? I mean, we're talking about units that can pull up to 100 pints of water out of the air every single day.
Think about that volume for a second. 100 pints is roughly 12.5 gallons.
That is insane.
Imagine 12-gallon jugs of water just floating invisibly in the air beneath your feet, constantly trying to rise into your living room.
That is such a wild mental image.
But by installing a system that aggressively extracts that moisture and keeps the relative humidity locked below 55%, you permanently alter the thermodynamics of the home.
You're changing the entire ecosystem.
Exactly. You prevent mold, you protect the structural floor joists, and you dramatically reduce the latent heat workload on your HVAC system. That calibration alone can easily save a homeowner $30 to $60 per month on summer cooling bills.
That is incredible. Before we move on to how we protect the actual machinery of the HVAC unit, though, I want to pause to look at the sheer scale of this problem.
Sure.
Because if 12 gallons of water are hiding beneath a single-family home, imagine the HVAC nightmare hiding inside a massive corporate building.
Oh, it gets so much worse.
Right. This is why we need to highlight our sponsor, Hurricane Group. We've been talking about their residential protocols, but their reputation, and they are backed by over 800 five-star reviews. It extends to their commercial air duct cleaning in Atlanta, GA.
The commercial side of this is fascinating, really, because the stakes for indoor air quality are exponentially higher.
Oh, I bet.
Hurricane Group is the strategic partner for massive commercial facilities across the region. Corporate offices, medical facilities, retail centers.
Big, complex buildings.
Yeah, and when a 50,000 square foot building neglects its ducts, it leads to sick building syndrome. You have complex, moldy duct networks circulating pathogens that directly impact the health, cognitive function, and productivity of hundreds of employees.
And obviously, you cannot just bring a residential truck to a massive industrial complex.
No, you need highly scalable industrial equipment. They utilize massive truck-mounted vacuums and robotic crawlers to map and scrub multi-story systems.
Robotic crawlers, that is so cool.
It's very high-tech. And they adhere strictly to NADCA and OSHA safety guidelines, which is critical for facility managers who have to maintain compliance with strict health codes.
Makes sense.
But the return on investment is what really stands out. Their commercial air duct cleaning in Atlanta, GA process, involves deep cleaning the massive HVAC coils and blowers. Removing that industrial-scale sludge can reduce a commercial facility's energy consumption by up to 25%.
That's massive for a big building.
Huge. And they handle the logistics with zero disruption, offering 24/7 scheduling, so crews are in and out during nights or weekends before a single employee arrives.
That level of engineering and professionalism is exactly why they are the leaders in Atlanta. So if you are listening to this, whether you are a homeowner sweating in your home office or a facility manager dealing with skyrocketing energy costs and sick building syndrome, do not wait. Call the sponsor now, Hurricane Group phone, 404-236-6343. Take control of your building's health today.
Definitely, it's so important.
All right, so let's connect the final pieces of this puzzle. We've stopped the house from inhaling basement swamp water by encapsulating the crawl space. We've scrubbed the lungs clear of Georgia sludge.
We've optimized the environment.
Right, but the air handler, the physical machinery, the heart itself is still vulnerable. If we don't give the heart an immune system, those clean ducts are just going to get reinfected the second the pollen comes back, right?
Exactly. And the immune system of any HVAC unit is the air filter.
Okay.
But the standard 1-inch fiberglass filters most people buy at the grocery store are practically useless against the microscopic particulates that cause sludge.
Really? The ones you just slide in?
Yeah, those cheap filters are essentially designed to catch boulders.
Yeah.
Things like pet hair, lint, large dust bunnies. They're just there to stop them from physically striking the blower motor.
Oh, I always thought they were cleaning the air.
A lot of people do.
Uh.
But they do virtually nothing to stop the fine 1-micron particulates from passing right through and entering your airstream.
So what's the alternative?
To actually protect the system, you must upgrade to high-capacity media filters.
Ah, I was looking at these media filters, and they look like giant accordions compared to the flat paper filters. I assume that thick pleating is designed to give them massive surface area?
That is the entire secret to their design. They are usually 4 to 5 inches deep, and because they are so heavily pleated, they have up to 40 times the filtering surface area of a standard filter.
40 times? Wow.
Yeah, and they operate at MRV ratings between 11 and 16. That means they act as a microscopic net, trapping 98% of airborne particulates down to a single micron in size.
That is serious filtration.
And because the surface area is so vast, the dust spreads out. They don't get choked and clogged in 30 days like the cheap ones. A good media filter can actually last 6 to 12 months.
Okay, but this brings up a major mechanical question for me.
Go for it.
Imagine trying to run a marathon while breathing through a thick wool blanket. Your lungs might have the capacity, but the physical resistance of the blanket is too high. You just suffocate.
That's a great visual.
Right. So if I pull out my flimsy paper filter and jam a thick 5-inch medical-grade MRV 16 filter into my air conditioner, won't the physical resistance suffocate the blower motor? Won't that just recreate the exact airflow restriction we just fixed?
That is a brilliant analogy, and it is the exact reason why proper HVAC maintenance requires certified specialists, not just guesswork.
So you can't just DIY it.
No, you really cannot just jam a high MRV filter into an older system. Before any advanced filtration is installed, a technician must perform a static pressure test.
A static pressure test. So they are measuring the actual aerodynamic force inside the system.
Exactly. Think of it as taking the blood pressure of your home's respiratory system. They use specialized gauges to measure the exact resistance the blower motor is facing.
Making sure it can handle the blanket.
Right. They need to ensure the motor actually has the horsepower to pull air through that dense wool blanket of a filter without straining.
What happens if they don't test it and it is too much?
If the static pressure is too high, the motor overheats, the airflow drops to zero, the indoor coils literally freeze into a solid block of ice, and those furthest rooms get no air at all.
Which puts us right back where we started.
Worse, actually, because you might break your unit. But when a specialist calibrates it correctly, sometimes by slightly modifying the ductwork to widen the intake, it provides hospital-grade purification with perfectly balanced airflow.
Okay, so the media filter acts as a fortress wall, stopping the dust from ever reaching the heart. But what about the things that bypass the wall?
You mean on the coils?
Yeah, the evaporator coils inside the AC are dark, and because they're constantly pulling moisture out of the air like a cold soda can on a hot day, they're constantly dripping wet. And we already know mold loves dark, wet metal.
This is where we bring in the heavy artillery, UVC germicidal lamps.
UV lights.
Yeah, and this isn't a new gimmick. It is the exact same ultraviolet technology used in hospitals to sterilize surgical suites and water treatment plants.
But how does a light bulb actually clean a metal coil? It's not wiping anything away.
It works on a biological level. When you install these high-intensity UVC lights directly inside the air handler, they shine a continuous spectrum of ultraviolet light directly onto those wet evaporator coils.
Okay.
When a mold spore or a virus passes through that light, the UVC photons physically penetrate the cell wall of the microorganism. The energy from the light literally shatters the molecular bonds of their DNA.
It destroys their genetic code so they can't replicate.
It completely neutralizes them.
Yeah.
They cannot reproduce, which means they cannot form what technicians call bioslime.
Bioslime, another lovely visual.
I know, right? Bioslime is a sticky biological matrix that loves to grow over wet AC coils. And from an engineering standpoint, bioslime is a massive problem because it acts as an insulator.
Oh, so it blocks the cooling.
Exactly. If your freezing cold coils are wrapped in a blanket of slime, they cannot properly absorb the heat from the air blowing over them. It blocks the heat transfer process. But by using UV light to keep those coils clinically bare and sterile, the system maintains maximum heat transfer efficiency, which can independently reduce your energy consumption by another 15%.
It really is a game of inches, isn't it? It's amazing how all these seemingly invisible inefficiencies, the quarter inch of sludge in the ducts, the latent heat rising from the crawl space, the microscopic layer of bioslime on the coils, they all compound and stack up.
And they cost you money.
Right. And the end result is you sweating in your home office while your power bill just goes through the roof.
Exactly.
Now, we have spent this whole time talking about how the house inhales, right? How it treats the air and how it circulates it to keep you comfortable.
Yes.
But a respiratory system also has to exhale. And if the house's main exhaust pipe is compromised, you aren't just losing energy efficiency, you are actively building a bomb inside your walls.
That's a strong way to put it, but it's accurate.
I'm talking about dryer vents.
The exhaust system is absolutely critical. A clogged dryer vent is one of the most dangerous, overlooked hazards in modern housing.
I saw the stats on this. It's terrifying.
The data shows that clogged dryer vents are a leading cause of residential fires. They're responsible for over 15,000 fires annually in the United States alone.
15,000 fires, and when you break down the mechanics of a dryer, it makes terrifying sense.
It really does.
Lint is just pure, dry surface area. It is incredibly flammable. Like, survivalists literally pack dryer lint into their kits to use as tinder to start campfires.
Yep.
And your dryer is taking that tinder, packing it into a metal pipe, and then blasting it with massive amounts of high-temperature heat.
It is the absolute perfect recipe for combustion. But even before it sparks a fire, the mechanical back pressure ruins your appliance.
How so?
When the hot, moist air is blocked by a wall of lint, it reflects back into the dryer drum. The high-limit safety thermostats inside the dryer detect that dangerous heat spike and shut off the heating element prematurely to prevent a fire.
So it's protecting itself.
Right. The drum keeps spinning, but it's tumbling your clothes in cold, wet air.
Which is why you have to run the same load of towels 3 times just to get them dry.
Exactly. And by using professional mechanical scrubbing and high-pressure flushing to clear that exhaust pipe all the way to the exterior of the house, homeowners instantly reduce their drying time by up to 50%.
That's a huge time saver.
And money saver. The machine doesn't have to fight the back pressure. That translates to saving $15 to $25 on your monthly utility costs, simply because the 220-volt heating element isn't running twice as long.
And there are very specific physical warning signs everyone should check for today, right? Like if your clothes take more than 1 cycle to dry.
Yes, that's a big one.
Or if the physical metal exterior of the dryer feels unusually hot to the touch. Or, and this is the easiest test, if you go outside while the machine is running and the little exhaust vent flap on the side of your house isn't blowing open.
If that flap isn't open, the air is trapped.
Those are massive red flags. Do not ignore them. So what does this all mean for you?
We started with a wildly common, deeply frustrating problem. Uneven cooling and rooms that just never feel comfortable no matter what you do.
A problem almost everyone has.
Exactly. But what we've learned by breaking down the physics and the biology of the home is that the solution isn't just buying a bigger AC unit or putting a louder fan in the hallway.
No, those are just Band-Aids.
Right. The definitive engineering solution is treating your home as an interconnected respiratory system. Clean and maintained ducts, free of friction-causing sludge.
Plus an encapsulated crawl space.
Yes, to stop the thermodynamic drain of the stack effect and advanced static pressure-tested filtration to protect the heart of the system.
It's a whole home approach.
Together, these steps don't just improve your indoor air quality. They permanently balance the airflow, they massively lower your monthly energy bills, and they ensure that every single room in your house receives the even cooling it was actually designed for. But achieving that delicate balance requires real precision. You cannot guess at aerodynamic static pressure, and you certainly shouldn't attempt negative vacuum containment without industrial equipment.
Don't DIY the negative pressure.
Exactly. Consulting certified HVAC specialists is the only way to ensure these interconnected systems are calibrated safely and correctly.
And that is why we are reminding you to take action and call our sponsor. Call the sponsor now, Hurricane Group phone, 404-236-6343.
They're the ones to trust with this.
Absolutely. Whether you need residential duct cleaning, commercial air duct cleaning in Atlanta, GA, or full crawl space encapsulation, they are the experts. Take control of your home's health, lower those energy bills, and fix that stubborn hot room once and for all.
You know, this whole discussion raises an important concept, though, and it's something I want to leave everyone pondering.
What's that?
We spend an unbelievable amount of time, energy, and money obsessing over the visible aesthetics of our homes. The paint colors, the hardwood floors, the kitchen countertops.
Right, the stuff we can see.
Exactly. But the most crucial components dictating our daily cognitive health, our respiratory comfort, and our financial energy costs are entirely hidden behind drywall and buried beneath floorboards.
That is so true.
So ask yourself, what other invisible infrastructure in your living space is silently impacting your daily life, just waiting to be diagnosed?